Hello everyone. Now we are going to implement in Python the vanilla version of the nearest neighbor classifier. Okay. So first, here we're gonna get. So as usual, we are going to use NumPy and pandas, and also we are going to get some data from sklearn library. This dataset in particular is a database for classification with continuous variables. So let's name our class column as class, and we are going to just load here the data. Okay, so now our data frame is going to be built from our data. Usually in the field data, it is contained the information, and the columns are in the field called feature names. And then we need to add the class column. They save it in the target field. So let's see how this data looks. It's something like that, okay? So there are 31 columns in this case, and mostly are continuous variables. So let's do some exploration. First, let's build this array, because we know that the variables are all the columns but the class name, okay? Or we are going to be using this this list a lot, so we better build it once. There we go. So those are the variables we are going to be dealing with. We can create a histogram to take a look of the distribution of each of the variables. And this is very simple with the pandas, because they provide us with this function. Let's use 20 bins, which is basically the resolution of the grid. This is the size of the total figure where pandas is going to put all our histograms. And we can define a layout. Basically is how many histograms we want per row. Let's say it's going to be 8 rows and 4 columns of histograms. And let's define also the size of the labels. With no grid, and let's use orange color. Oops, sorry, this is fixed size. Cool, so here we go. Here we have all the histograms, and then you can take a look of the distributions. One thing we can notice here is like the ranges or values of the variables are quite different among the variables, right? Some of them are between the ranges of hundreds, others are between 0 and 1. So this is going to affect the performance of the nearest neighbor algorithm, because it is using a distant metric that usually compares all the variables as if they had the same importance, right? So let's standardize the variables. So usually what we do here is like we subtract the mean and divide that by the standard deviation. So let's go over all the variables, right? So this is gonna be divided by the standard deviation. Okay, so now let's do the same thing, but now we can plot the histograms of the standardized. We can use another color here. Okay, here we go. So now we can see that mostly all of the variables are now centered in 0, and we're not going to have the same issues with the ranges of the variables. There are other alternatives for standardization or for normalization of the variables, like the min-max, but we are going to see that later in other videos. Another interesting thing we can do here is to visualize pairs of variables, kind of like having a look on how the classes are separated between them. In this case, we have two classes. We can use one library called Seaborn, which is a very nice library to create some visualizations. Yeah, this library is very easily installed. You just need to do pip install and the name of the library, and that's it. Here we need to provide with the class name, and that's it. I mean, now Seaborn will realize how to put the colors on the points according to the class they belong to. So we can easily see how the classes are separated. In this case, this is a binary classification problem, and we have two different classes, which are, so actually before running this, you guys can see here, like if we do df of class name dot unique, then we just have two classes, right? 0 and 1. So if we run this command, we are going to get all the pairs of variables with the data points colored according to the class they belong to. Okay, here we go. So we can see it's a very nice plot with all the possible pairs and with orange and blue colors for the different classes. So we can take a look, and we see that mostly if we just look at the pairs, the classes are kind of separated. In some cases are not, but this is in general a very nice classification database where we know that the problem is gonna be solved by using any good classifier. So probably we wanna get good results with the nearest neighbor classifier. Okay, so now let's start implementing some functions. So the first function we're going to need is the distance, of course, and it's going to receive any two data points, and we'll just return, for now, the Euclidean distance will be fine. So here we have the square root of the sum, and then here we can just build the list of the square differences, right? Okay. So let's try this. Distance between, for example, these two data points. Okay, so let's now define the function called an classify that is going to actually perform the classification, right? So it's going to receive one data point X, and it's going to receive the training data, and the class name is going to be necessary to know which column contains the class. And of course, the number of neighbors that we can by default use 3. This function is going to need the distances to all the other data points, okay? We can say them in an empty list for now. And again, we're going to need this array. Unfortunately, we have to build it again because we are inside the scope of the function. So now we are going to save the distances to the data points, and in order to keep track of the data points, we just need to save the index of them, right? So we are going over all the index values. We are going to calculate the distance using our function. So we want to calculate the distance just using the variables, and let's pass it to an NumPy array. This function is provided by pandas. So this is the first, and then we need to compute the distance from every training case to X, right? So in particular, it's going to be X, also just the variables. And here we are assuming that X come again as a pandas data frame, right? So we gotta make sure that all our data always, even if they are data points, they must come as pandas data frames or series. So here we are going to append a tuple with the index and the distance. Now we have the distances, so let's assume we're going to implement another helper function that will return the neighbors given the distance list. We're going to call it get neighbors IDs. Okay, so this function is going to just return the k nearest neighbors. The classes of the neighbors are going to be here because we are going to extract the class of all the training set indexed in the neighbors we just found here, right? So basically here saying, bring me the class of all the nearest neighbors. And now we need to return the most frequent class. With this function from pandas. This is returning the value that has a higher count.